Hello students, welcome back to this new session. Here I have come up with the same topic of inverse Laplace transform. I'll be working with some more problems on inverse Laplace transform of the same type by completing square method. Okay, so here is one problem for you as you see it on your screen. It is find the inverse Laplace transform of s divided by s to the power 4 plus 4a to the power 4. Okay, so it seems like very different type of this, but it's very simple as you go with the solution. Take a pen and a paper and start working for the same problem with me. Okay, solution goes as, see here, I first want to simplify the denominator. That is, I just don't want it is in terms of like this. That is, s to the power 4 plus 4 into a to the power 4 can be written as s square plus 2 times a square whole square. So the expansion for this becomes what? S to the power 4 plus 4 times a to the power 4 plus 4a square s square you all will get. But I do not want plus 4a square s square. So what we will do? We will subtract that thing from here. 4a square s square. Now everything, it can be written as 2 times. I will rewrite this once again. It will be clear to you. It is s square plus 2a square whole square minus 2as whole square. Now it is taking the form of a square minus b square form. So that can be written, now you know already, how can you write a square minus b square? It can be written as a plus b into a minus b. Is it not? So the same I am going to do here. So this will be equal to s square plus 2 times a square minus 2as s square plus 2 times a square plus 2as using this formula. Okay, so once you that is the denominator can be written in this way. Let us see about the numerator. Now if you consider the same two brackets, if I simply subtract this from this, that is if I consider what is s square, okay, I can write, 1 minute, I can write 4as as s square plus 2a square plus 2as minus s square plus 2a square minus 2as. Can I write it like this? See, plus s square minus s square gets cancelled, plus 2a square minus 2a square gets cancelled, plus 2as minus of minus plus 2as gets you 4as. Is it not? So I want s from here. It will be 1 by 4a s square plus 2a square plus 2as minus s square plus 2a square minus 2as. Complete the bracket. Means the numerator simple s can be written in this bracket form and the denominator can be written in this way. So I will replace the numerator and denominator by these two things. So what do we get? So therefore s divided by s to the power 4 plus 4 times a to the power 4 equals, let us write the numerator first. It is 1 by 4a, that is this thing, that is s square plus 2a square plus 2as in one bracket minus s square plus 2a square minus 2as in another bracket divided by, the denominator is s to the power 4 plus 4 times a to the power 4, which can be written in the product form of these two brackets only. So let us write it. It is s square plus 2a square plus 2as into s square plus 2a square minus 2as. Now all you need to do is just separate the terms, that is the numerator divided by the two. First numerator, that is the first term, the first bracket divided by two brackets, then the second bracket minus the second bracket divided by the two brackets. So you will get this to be 1 by 4a. So if you divide the first bracket with the two brackets, so one of that bracket will get cancelled. You will be left with 1 divided by s square plus 2a square minus 2as in the first term. Whereas the second bracket, if you just take the second bracket minus the second bracket by the two brackets, means this one and this bracket will get cancelled. You will have s square plus 2a square plus 2as left here. Is it not? Okay, now 1 by 4a. This thing I can write it as 1 divided by s square minus 2as plus a square plus a square. That is, I am splitting 2a square as a square plus a square. Similarly, I will do it here. S square plus 2as plus a square plus a square. Now, if you just consider only the first 3 terms from here, you will see it to be s minus a the whole square. Similarly, if you just see the first 3 terms from the second term in the denominator, you will have s plus a whole square, that is this and this over here. Just see that, okay? I will just replace by that, by those brackets, 1 divided by s minus a whole square plus a square as it is, minus 1 divided by s plus a whole square plus a square. Now take the L inverse on both the sides. Therefore, L inverse of s divided by s to the power 4 plus a to the power 4 into a to the power 4 is equal to 1 by 4a is however constant, get it outside. L inverse of the first term, I will take a bigger bracket here, 1 divided by s minus a whole square plus a square, L inverse of this first, plus, there is a minus sign in between, minus L inverse of 1 divided by s plus a whole square plus a square, and complete the bigger bracket as well. Okay, I hope it is clear up till here, all of you. Now this is equal to 1 by 4a. Now see here, the first term, if you see, in place of simple s you got s minus a whole square, and similarly here in the second term you have got s plus a whole square. Previously in my previous session itself we have solved a problem on this, so I am going to use it the same way. Okay, if you want to eliminate that s minus a, you need to you have to write e to the power at, because it is s minus a over here. L inverse of, keep the s as it is now, this one thing, minus, here also e to the power minus at becomes, because e to the s divided by 1 divided by s plus a whole square plus a square you have got. In place of simple s you have got s plus a whole square. So definitely there should be some exponential term there by using the property of Laplace transform. So using that, now replace your s plus a the whole square by simple s. You will have this, complete the bigger bracket as well. Okay, and now this thing, I'll just continue it here. So it will be 1 by 4a e to the power 80. What is its inverse Laplace transform? It is 1 by a sin 80 minus e to the power minus 80, 1 by a sin 80. This is what you get, is it not? Now this can be written as, I can take a common, I can take sin 80 also common. Okay, so we will be getting this as, you have 1 by 4a square, not 1 by, sin 80 also you are taking outside. So sin 80 divided by 4a square into e to the power 80 minus e to the power minus 80. Now one of that, there is 4 already in the denominator. I shall continue it here, just see. There is 4 already in the denominator. It can be equated as sin 80 divided by 2a square into e to the power 80 minus e to the power minus 80 divided by 2. 2 into 2, it's again 4 over here. Okay, that is what I am doing. So sin 80, now what is this? It is sin hyperbolic 80 over 2a square. This is the required inverse Laplace transform for this problem. Okay, I'll continue with one more problem of the same type here. Just see here. Yes, here I have got one more problem of the same type. Find the inverse Laplace transform of this. Okay, already in my previous problem we have seen the simplification for the denominator and also when it's simple s in the numerator. So I'll just use the same previous problem direct things. See here, I know that s to the power 4 plus 4 times a to the power 4 can be written as s square plus 2a square minus 2as into s square plus 2a square plus 2as. This thing we have seen it in the previous problem itself, so I am directly using it. Similarly, s can be written as 1 by 4a s square plus 2a square plus 2as minus s square plus 2a square minus 2as. This things we have already seen in my previous problem. I am just continuing the same thing. Okay, so this thing can be written as s. So we know that s square divided by s to the power 4 plus 4 times a to the power 4 can be written as s into s divided by s to the power 4 plus a to the 4 times a to the power 4. Is it? Now this thing we have written already in my previous problem. I'm directly using it. So s divided by 4a, it becomes the simplified form. Directly I would have chosen it from there, but in beginning I have just taken it because I have already erased everything, so that you should not get confused. See, you have 1 divided by, earlier you had it to be, once you wrote s divided by this divided by the bracket, you got the negative bracket first, so that is it was something like this. The simplified form for s divided by s to the power 4 plus a 4 times a to the power 4 was something like this. Just check it, all of you. S square plus 2 times a square plus 2 times as. Okay, it was like this. Now I'll take this s inside. So you will have 1 divided by 4a s over s square plus 2a square plus minus 2as minus s divided by s square plus a 2 times a square plus 2as. Now the story remains the same. Only thing is that the denominator, you will have it something like this. 1 by 4a as it is. The denominator is s divided by this. Also we have solved in my previous. It can be written as s minus a whole square plus a square minus s divided by s plus a whole square plus a square, something like this. Okay, now there is one single problem. Earlier there wasn't s in the numerator. Okay, you had simple 1, so it was very easy to work for you, but now there is s in the numerator. If it is s, it should be in the same pattern as it in the denominator, so that we can directly simplify using the property of the Laplace transform. But here there is a simple s in the numerator, so you are going to match it with the denominator s so as to use the property directly, because the property says what? If you remember it properly, I hope it will be easier for you to solve this. It is e to the power Laplace transform of e to the power at into f of t. It was to be f bar of s minus a, where your f bar of s is the Laplace transform of f of t, is it not? So wherever you had simple s, you get everywhere s minus a. Okay, by this property. Now if I want to reversely use it, means what? Everywhere if it is s minus a, only then I can use the inverse this property to work. Okay, otherwise it is not possible for me. So that's why, see here, the denominator is s minus a, but the numerator is s only. Here also it is s plus a, but there is s only. So I have to make the numerator to the same way how it is in the denominator. If it is s minus a here, I should make it s minus a here, then only I can use it. Okay, if it other than s, if it is some constant, then it will be easy for me to work, but that right now it is not that easy, because there is s minus a in the denominator and s in the numerator. So we'll do one small step here. It is 1 divided by 4a into, I can write it as s minus a plus a. I hope it is clear to you, so that these two things will, okay, minus, similarly s plus a minus a, s plus a whole square plus a square. Is it? Now it is 1 divided by 4 times of a, and you have to separate it now. S minus a divided by the same bracket, sorry, s minus a by the divided by the denominator same, okay, plus a divided by the same denominator. Just see here, means in place of 2 terms you will have 4 terms, something like this, minus s plus a divided by s plus a whole square plus a square, and minus of minus plus a divided by s plus a whole square plus a square. I hope it is seen there. Okay, now see, this is what you get. Okay, now we'll take inverse Laplace transform. Therefore, L inverse of s square divided by s to the power 4 plus 4 times a to the power 4 will be what? 1 by 4a is constant, keep it outside. We'll just see for individual terms now. Take a bigger bracket, L inverse of the first bracket plus L inverse of the second bracket, second term I mean to say, minus L inverse of the third term okay, plus finally the last term L inverse now complete the bigger bracket as well. Okay, now I'll continue it here 1 by 4a. Now as usual everywhere you see either it is wherever it is s, either it is s minus a or it is a constant. If there is no s in the numerator, there is a constant. If there is s, it is matching the denominator. Sorry, it should be s plus a over here. Please correct all of you. Oh yes. Now here since it is s minus a there, so definitely it should be e to the power at accompanied with your main f of t. So L inverse of remaining term, that is s divided by s square plus a square, you will have that you need to change obviously. Then you have e to the power at again, L inverse of a divided by s square plus a square. Similarly minus, you will have e to the power at, minus at this time, L inverse of s divided by s square plus a square. And finally the last term, that is plus e to the power minus at L inverse of a constant a divided by s square plus a square. Complete this bracket and complete the bigger bracket. This is what you get. Okay. Yes. Now 1 divided by 4a, e to the power at as it is nothing but cos at plus e to the power at sin at minus e to the power minus at cos at plus e to the power minus at sin at. Okay, now from these two terms you can take cos at common, and from these two terms you can take sin at common, and take your one of the a inside this, one of the two inside this. So 1 by 2a will be left here. Okay, so I'm just taking 2a over here. Just see, if I take cos at common, it will be e to the power at minus e to the power minus at over 2 plus, if I take sin at common, you will have e to the power at minus e to the power plus e to the power minus at over 2. Now this 2 also you can take common, it becomes 4 here, there is no difference. Now this is nothing but what? Sin hyperbolic at, and this is cos hyperbolic at. All you need to do is just simplify it that way and keep the final answer. Okay, I shall write the final answer here. Just see, therefore L inverse of s square divided by s to the power 4 plus 4 times a to the power 4 is equal to 1 by 2a. First you had got cos at sin hyperbolic at. Okay, cos at into sin hyperbolic at plus sin at into cos hyperbolic at. This is the required solution for this type of problem. Okay, if you have any doubt, do ask me in our WhatsApp group. Till then, thank you.